policies. So let me explain how intrusion IPS works. At first, it's like, I don't know, it's smoke and mirrors, right? It somehow knows when an intrusion happens. Like anything security or anything really at all, everything is explainable. So here's how intrusion policy works. All applications, including operating systems and firmware and such, right? Those are created by human beings. Well, today they are, right? That are typing in this code. And those human beings are susceptible to errors and mistakes that can leave vulnerabilities in that software, right? Vulnerabilities that can be exploited. So two terms, vulnerability and exploit. The vulnerability is a weakness in an application or in a device, because a device runs software, that can be exploited, the action of compromising that device to gain access to that device, to mirror any traffic that's going through that device, to exfiltrate data, or to jump on it and use it, take it over, maybe launch a shell, and use it as a launching point for attacks from the inside. So does that make sense how intrusions work and vulnerabilities and exploits? Okay. So what intrusion prevention does is it watches for those exploits. It ties in through Talos, Cisco Talos, and Talos has this gigantic database of all potential exploits. And so it knows what exploits there are pertaining to, so let me back up a bit, pertaining to your environment. Only the ones that are pertaining to your environment. It knows those exploits. So it's watching for that. And when it says, hey, I see this exploit attempt, however it recognizes that in a string of characters or whatever, it says this is an exploit. Somebody's trying to exploit this vulnerability, and I'm just going to drop that traffic. Okay? So that's kind of similar to how antivirus works, something like that too. We're going to go, before we can build our intrusion policy, we need to define a few objects. So we need to build some objects that we plug into our intrusion policy. So we can click on Objects and Object Management, and we're going to scroll down in this vertical navigation bar to find Variable Set. Okay? In Variable Set, you'll find just one variable set called Default Set. That's fine, we'll leave it there. But we're going to edit that. So let me know when everyone gets to this point. Cool. So yeah, we're going to edit the default set. Okay. And so in the default set, I have two screens here. This screen first, we're going to scroll down, and these are all the variables. So these are actual variables that are used in Snort rules. Snort's the intrusion prevention engine, right? The IPS engine. And that's just programming code, some smart guys coding how to detect exploits. And so these are variables, $homenet, $externalnet, DNS servers, et cetera, are actually in the code. So we want to help IPS be efficient at that. We want to modify the home net. So go to home net and click on the pencil. And what we're telling the home net is home net equals our LAN, not the internet. It's our LAN and DMZ, just anything that's not the internet. That's what home net is. So again, we're going to be scalable, and we're just going to add RFC 1918 to that. So that's the IPv4 private, that network object, right? Add that over there and save it. And that is a change, right? Initially, you'll notice it's not configured at all. And there are rules that are specific to traffic that's sourced from the inside and destined to the outside, or sourced from the outside and destined to the inside, and they depend on that variable being correct. So we've just defined our home net variable. Let's move on. Once you got that in and saved it, now we're going to find the external net. Guess what external net is? That's the internet. So how we do external net is we find the variable home net that we just configured and add it to exclude. So home or external net is everything on the planet except for what's on our LAN. Does that make sense? When you add it in there, it'll actually show as an exclamation point home net. So you know, now you see that as a variable like the not home net, if you will. Okay, so it's just two things. We got our home net, which is our internal, and our external net, which is not internal. That makes sense to everyone? Yeah, so that's really making a big difference on the efficacy of your intrusion policy. Then from here, so we just defined those objects. They're just variables. Now we're going to click back over to policies. And when you notice some policies, before you click in here, you'll see all these different kinds of policies. We already looked at discovery. But all these, the intrusion policy, the malware file, DNS, identity, SSL, we're going to configure all of those, and then we're going to reference those in the access policy. The access policy is actually the last one you do. So we'll start with the intrusion policy. So policies, intrusion policy. You'll see this. Okay, when you see this, we're going to edit the one that says dcloud balanced intrusion. Okay, there's another one in there that won't be referenced here. So here you are. What we're going to do with this intrusion policy is we'll change that balance down here to security over connectivity. So I was trying to explain. The set of aggressiveness. So if you have security over connectivity, it's gonna lean more towards security than connectivity. If you have connectivity over security, guess what? It's the opposite. And then balanced is somewhere right in the middle. I think it defaults to balanced, right? Cisco recommends, and I recommend, you actually switch that up to security over connectivity. That does increase the chance of false positives, which means you might need to then add in, thanks, appreciate you. You might need to add in an exception. So let's say you're putting in these policies and then something's triggered, but the application's actually valid. You can just put in an exception for that one particular one and still have security over connectivity. So you're still overall very much more connected. And it's actually significantly higher protection security over connectivity. So that's what we recommend. And then when you do that, then you'll have to rename this, or you should, just so it has a more accurate name. So just switch it up to dcloud security over connectivity at the top, and then save that. Does that make sense to everyone here? Don't ever use maximum too much. You'll be making exceptions for everything. So we'll save that then, and then we're back here. And you'll notice we're up here at this little screenshot. And we're going to notice that we're on the Snort 3, or click on rather, the Snort 3 version of that same rule, the dcloud security over connectivity. And it shows up like this. Okay? And if you actually scroll down here, you'll see all these rules. Don't mess with those. That's the rules. That's the Snort rules. If you have to make an exception, give us a call or a Cisco tech. Okay, it's deep, so it's not for the faint of heart. I've done it before once, and it required some very careful consideration. I usually don't have to. When you come in here, you notice that as we go through this little flow, that recommendations is not in use. What is recommendations? I'm glad you asked. So recommendations is this. We've done our discovery policy. We've learned our contextual security database. We know the firewall knows everything, or the FMC rather, knows everything that's on your network. Hosts, users, applications, in particular, hosts and applications. It can take that, send it to Talos and say, Talos, give me a policy that I can tweak here and turn off the things that don't pertain to me. If you don't have Red Hat version 7, you don't need to have the rule running. Keeping in mind that intrusion policy means I'm evaluating all this traffic against all of these rules. So the more tuned your database is, the more efficient that is. You don't want every rule turned on if it doesn't pertain to you. Also keeping in mind that the discovery policy continuously works. So as you add new applications, new versions and such, it updates itself. And then this, again, can be set to scheduled to update itself as well. So you have an always up-to-date intrusion prevention system, self-tuning. Does that make sense, all of that? Yeah. So click over here and click on Not in Use. Let me see here. And when you click on Not in Use, then you get this. So first we're going to click Accept Recommendations to Disable Rules. And want you to add the IPv4 private addresses. You won't find that other unified one. You got to add it individually. So it's IPv4 private 10. Et cetera, private 172.16, private 192.68. This guy, you went to click on Not in Use on the intrusion policy. So you had your dcloud. You clicked on the Snort 3 link over there, and then you clicked on Not in Use, and you're just adding these three and clicking Accept. When you've done all this, click Update, and it'll spin for a couple of seconds because it's actually taking all that stuff, sending it up to Talos, twiddling its thumbs, waiting for it to come back, and applying it to your configuration. You can also, in any of these search engines, start typing, and it's much easier than trying to scroll around and find it. I guess I could have told you that before. Because it's sometimes hard to find. There's a lot of objects. You're just adding them individually and clicking Accept. And if you don't get it right, don't worry about it. I mean, it's just you get the idea by seeing this. Okay, again, when you click Update there, then it thinks about it for a minute. Right? Everyone up to date now? Anyone nod with me? Okay. Okay, so malware and file policy. So we worked on intrusion, and now we're working on malware and file. So here's how malware, anti-malware works with Cisco Secure Firewall. Is anyone familiar with AMP for endpoints, now called Cisco Secure Endpoint? Okay. So I want to do a brief overview of how that works, because it does relate to this. with AMP for endpoints, we'll compare that to a point-in-time antivirus. A point-in-time antivirus, another one, would be such that if a file is introduced to a system, that you're comparing that file to a list of signatures, right, on your endpoint to say, does this file match these signatures? It's just a list of signatures. No, 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 no. And if it does, then it drops it. If it doesn't match it, then it lets it through and it never looks at it again. Okay? That's point in time. So, and it's got two dispositions, known bad or unknown. Okay? How Cisco Secure Endpoint works, or the AMP technology, used to be called AMP for endpoints. Then, like I said, they rebranded everything with Cisco Secure. How that works now is when a file is introduced to a system, it first calculates a SHA-256 of that file. So that just means it gives it a string of characters as a name tag. This file is this name tag. If the file is renamed, it still has the same SHA-256. It's easier to work with just a string of characters than it is to work with a whole file, right? It's quicker, more efficient. So the first thing it does is it looks in its local cache for a disposition to see for files that are frequently accessed, Outlook or Word or anything that's open frequently. And it has three dispositions. It's either known good, meaning I've already fully checked this out. You or someone else on the planet has fully checked out the SHA-256. It's clean. I don't need to reevaluate it. Or known bad, same thing. You or someone else on the planet has already reevaluated the SHA-256. It's bad, so we'll drop it, and now we won't talk about it anymore. Or it's unknown, meaning it's new. Like, let's say you just created a new Excel document. Brand new. Nobody's seen it before. Or you received one. Nobody's evaluated it. It's brand new, and it can be malware. So now it's got to say, well, this is unknown. I need to look this up in the AMP cloud. So the AMP cloud is part of the Cisco Talos Threat Intelligence Database. Basically, it's a giant database in the sky, if you will, of dispositions to SHA-256s of all malware that's ever existed. Okay, so compare that to point in time that has a finite list of signatures, and they really can only take a thimbleful of the ocean of malware. Because if they had all the malware, it'd be this giant list. And if you just think about it logically, it's looking through, is it this? No. Okay, is it this? No. Is it this? No. So it's got to be finite, or it would just take forever to do anything, right? So you're only looking at point in time for relevant, recent, popular malware. Whereas with the AMP technology, you're looking at all malware of all times, right? To make sure sometimes you get some resurging malware that comes back slightly morphed from back in the day, and it comes back and shows up again. So this AMP cloud looks up and says, okay, I've got three dispositions. This is either going to be known good, known bad, or unknown. And if it's unknown, because remember, you just created this. It's an Excel doc. It's a 0 day, if you will. So then it's going to say, all right, we're going to let this file through, but I'm going to take the whole file and I'm going to send it up to a sandbox environment. That sandbox technology used to be called Threat Grid. Now it's called Cisco Secure File Analytics. And it detonates this file literally in a Windows, right, a desktop environment. You can actually watch a video of it. And it'll show you, it detonates, looks for indications of compromise, it analyzes the structure, compares it to other malware, checks for heuristics, all the stuff that malware does. And then it finds a disposition of this, either known good or known bad, and plugs that into the AMP cloud so that the next person on the planet looking for that SHA-256 doesn't have to go through all that again. It already knows it. So you see how it's kind of for the people, by the people? So then you're saying, wait a minute, I let this through. And it takes about 7-8 minutes to do that sample. It's just got to analyze the file, right? It can't be instant. So during that 7-8 minutes, if this malware went through, well, Cisco Secure Endpoint actually runs on all the endpoints that it's installed on and does a full inventory of all the files running on the system. It's actually a lightweight connector, and all the magic happens in the cloud, so it's very efficient. But so if it goes through and we say, whoa, 8 minutes ago, we let this file through, and it was malware, so where's it gone? And we know all the endpoints where it's been, so it can reach out and quarantine that file, even if it's not being acted upon. Okay, that's what differentiates AMP from other antivirus. So the reason you're saying, well, I don't want to do that. Why don't I just make it sit and wait? Because as human beings, when we click download, we don't want to wait 8 minutes. We're going to go click, 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 click until it finally comes, right? That's what human beings do. So they're like, okay, we're going to let it through and we're going to check it. And so even if it comes through and says, oh, it's malware, it's been on these endpoints, you can at least still, remediate those and get the malware off of those, even if it's still in quarantine it. And it can communicate with any of the other technologies that's integrated with AMP. So Cisco integrates this AMP technology with Cisco Secure Firewall, with Meraki, with Umbrella, with, gosh, I can't even think of what else, a lot of other applications. Okay, so,
How do you get alerted that file?
great question. So when you get an alert in the firewall, so let me compare that to what the firewall can do, because the firewall is not a laptop, right? It doesn't have the full feature. So this can plug in to the AMP technology, and then when it sees what it can still say, I'm going to look at my local cache. It can still do a cloud lookup. It can still do a cloud analytics lookup. But if something comes back retrospectively, whether it's 8 minutes later or the disposition has changed for software that maybe has some anti-detonation technology in there, something that it's where it can't be detected right away. So maybe it's a week later or a month later or several months later and it says, whoa, this malware that we let by sometime back in the day, that was malware, so we need to do a retrospective alert. All the firewall can do is send you an alert to say, hey, this firewall went through, keep track of it. But if you're integrating your Cisco Secure Firewall with AMP for Endpoints, now known as Cisco Secure Endpoint, that communicates with your AMP for Endpoints environment to say, go out and find this and quarantine that file. Okay, so if it's just by itself, because you don't have to have AMP for Endpoints, it still works. It's just all it can do is send you a message to say, here's a retrospective alert. This is different. And it might be the opposite. Well, we thought this was malware, but we checked that out again. It's really not malware. Right? So Cisco's not going to come off and say, we're right all the time and 100% effective, and you will never get any malware intrusions. That's impossible. And Cisco's going to be upfront and honest about it to admit that you can only mitigate risk. You can't eliminate risk. Okay? So let's say you had that on email security that was integrated with an Office 365, Microsoft 365. That can then do some remediation to say, hey, this file that was let through at some point in the past that was attached to this email, that was malware. So now I'm going to go out into that mailbox and pull that mail back, remediation. So there's some auto remediation when it comes to email, but you understand with a firewall that it in itself can't reach out and unsend that. It has to either through or it's not. But when it ties into endpoint, though, that's when it can remediate. So does that make sense? The whole AMP technology and how all these security components work together as a security system? Yeah? Okay. So let's have some fun and configure a malware policy. So does everyone back into their FMC? Anyone not in their FMC? Great. Go to policies and malware and file. We're going to go to the TG file policy and edit it with the pencil. Okay, cool. When you're here, you're seeing the rules to that policy. That's the theme of the FMC, is you have policies and rules are part of the policy. I talked about that before. So first thing we're going to do is we're going to go in here and trash both of those rules because they're not tuned. And we're going to create tuned malware rules. Okay? So just trash both of those and let me know when you're there. After then it's empty. It's an empty policy. So then you're going to click on Add Rule. And then you'll get to this, and now I'm going to put you to work. Okay? We're going to create a new rule. Everyone up to this point where we're adding a rule? We're going to give it, okay, so this rule, our first rule is going to block malware. So this action block malware, okay? I should have got a stick or something. Anyway, we're going to block malware. We're going to select reset connection, and we're going to store the files. And we're going to come over here and select any of these things, these categories, and then within executable, only these file types. Okay? Oh, these are within executable. Sorry, I left off the executable part there, but they are. Okay? So we're being specific about it. Why am I doing it like this? Because these different engines are only applicable to certain file types and certain categories. So we can't just say all the file types do all this stuff, or when you save it, it'll give you an error message and say, these things aren't compatible with this. Right? It'll kind of make more sense as we go through it. So you don't have to get this perfect here, but you get the idea that you can set up a policy and you can set it up like this and you can save it. Let me know when you're done doing that. So any of these specific things aren't compatible with any of those engines, just reset connection. Yeah, so now we're gonna save that, and I'm sorry, but we're gonna do one more. Well, not one more, we're gonna do 3 more, maybe 4. So this one is a little different. We're still selecting block malware. We're clicking all the options. And we're doing unknown to store files, and we're only putting executable MSEXE in here. So that's your bulk of malware, is your .exe files, right? So it can be all these things it can run through. I'm going to jump back real quick. Oh yeah, I never really explained that. So Spiro is fuzzy fingerprinting, so heuristics. Dynamic analysis is threat grid. And local malware analysis means it can be analyzed locally on the firewall itself. So this is that rule again. Give me a thumbs up when you're done with that one a little. Okay, so, and then we'll do another one after this. Again, lightweight, but we're only doing dynamic analysis, local malware analysis, like that. And we're only doing the category dynamic analysis capable. No? All right, cool. So, and then another one easy, we're just going to do local malware analysis in that category that matches that. Just fine tune it. One more after this, then that's it. So what I'm getting at here with all of this is the firewall will be more efficient. Efficiency is important, right? You want it to move as fast as it can and tuned as possible to catch all this. And without seeing a bunch of errors and warnings, because when you go through and you see a bunch of orange triangles, you're like, well, is that legit or what? So you don't want warnings, you want it to look clean. Okay, and then one more rule. And that one is just detect files for graphics, encoded, and multimedia, just because I can't do anything with any of those. And I don't think those are malware capable yet. Okay. So, and now this part here, there's no lab for this because the dcloud environment doesn't have Cisco Secure Endpoint integrated with it, so you can just rest your fingers and watch me here for this one for about 3 slides. So you can integrate, as I mentioned, the Cisco Secure Firewall with Cisco Secure Endpoint. So firewall with endpoint. So you'd go under integration and AMP management, you'd add the cloud, you'd pick what country you're in here, or region, and then it says, hey, do you want to redirect to the AMP for Endpoints page, which I will call Cisco Secure Endpoint AMP for Endpoints for years now, I swear I will. And then it pops you over to the endpoints lab, or to their page. And it says, hey, somebody's trying to integrate with me. Do you approve of this? So then you can say, yeah, for these policies that whatever ones you have set up in your endpoint environment, I want to integrate those with the firewall. So then after that, then you save it. And then when you come back, and after that integration in your endpoints dashboard, if you go into management of computers, you'll actually see the FMC there participating. So why that's important is this. There's the ability to do a file tracker, a file analysis tracker. Gosh, I'm losing the term now. The ability to track all of your endpoints where files are going, file analysis. And that'll tell you in the AMP for Endpoints dashboard where file or files have traveled throughout your network for a particular file, right? It's been here, 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 and here. So that then will include the firewall in there so you can find patient 0, if you will, right? The first place that malware showed up. Does that make sense? And instead of just popping up on your AMP for Endpoints, now you can say, well, this just came through the firewall. Instead of, oh, this just showed up on Skippy's laptop while he was off at Starbucks, right? Makes sense? So that ties it all together, integrates. And also, the firewall notices something and pass that back up to your endpoint so it can take action on it. You just put gears into a machine. Make sense? Clear? Yeah. When you're doing forensics, which hopefully you never need to, but if you need to, then it helps you find the source of the problem.